Assalamu alaikum. Now we are going to start chapter 16. This chapter will discuss the concept of time series and forecasting. Time series is basically the collection of data recorded over the period of time, and forecasting is the assumption for the future on the basis of previous events. So let's see what are the goals for this chapter and what concepts we are going to learn in this chapter. So the first point is the study about or definitions of the component of time series. Then we will compute the moving average, which helps the smoothing out the time series data. Then we will determine the linear trend equation. If you remember in chapter 4, we learned about the linear equation. But now in this chapter, we will see how we will determine the linear trend equation. Compute a trend equation for a non-linear trend. So we will see that how we can compute a trend equation for the non-linear trend. Non-linear trend basically where the exponent have a x variable have a exponent more than 1. So use a trend equation to forecast future time period and develop the seasonally adjusted forecast. So we will see the usage of trend equation. Then we will determine an interpretation of sets of seasonal indexes and deseasonalize the data using a seasonal index. And at the end of this chapter, the topic of test of correlation is excluded from your course because it's out of your capacity to learn about at this stage. So in next semester you will study this test for autocorrelation. It's basically used to test the assumption of regression. One of the assumptions is there is no autocorrelation. So moving on to the next slide. Let me clear the drawings first. It looks messy. So the time series, what is the time series? A collection of data recorded over the period of time. That is basically weekly, monthly, quarterly, or it can be yearly. So it's an analysis of history. It can be used by management to make current TCN plan based on long-term forecasting. So they can project or forecast the future on the basis of the time series data. And these projection, long-term projections are more than 1 year. It can be a 5-year, 10-year, or more than that. Usually assume past pattern to continue into the future. So they assume that the company's operation will be follow the past patterns, and we might have the same situation in a future as well. So that is called the forecasting. Moving on to the next slide. So here are the components of the time series data. The secular trend, the smooth long-term direction of the time series. It means that the smooth long-term direction. So if this data has a smooth upward trend, the cyclical variation, the rise and fall of a time over a period longer than 1 year. So it can be like this rise, fall, and then rise, and then fall. So this is how the cyclical variation shows at the chart. Seasonal variation. So seasonal variation includes the data like, if we can say, the production of ice cream in winters it decreased, but in summers it's going to the its peak. So this is called the irregular seasonal variation, and then irregular variation, classified into two forms. The first is episodic and second one is the residual. Episodic is unpredictable. So what is the prediction? The prediction is basically we just assume something for the future, but we don't have any past experiences relevant to that. So the episodic variation is basically unpredictable but identifiable. So something that we can identify, but we cannot predict that a particular situation will be occur in the future. So the residual is basically also called the chance fluctuation and unidentifiable. So residual is basically unidentifiable, but there is a chance of fluctuation. So if we can say that this is the, for example, earthquake, and this is its aftershocks. So moving on to the next slide. So in this slide, we are going to study the cyclical variation, and let's see how a business face the cycle of up and down. So at this point, there is a battery sold mentioned on this coordinate, and the years are mentioned over here. So this blue line is basically showing the cyclical variation at this point. Business is prosper and growing, but when this line is decreasing and below the pink line, which is a secular trend, is below the pink line, is it at this point it shows the depression. Then this depression is prolonged to this time period, and then it started to increase or grow up, and then again it falls down and face a recession and then enters into a depression. So after staying in depression in two points, then this business recovers again and then see the prosperity. So this is how recession and depression works, or you can say this is how the cyclical variation works. Recession and depression are almost the same things, but recession, when we have a uh, downfall in consecutive 2 quarters, we can say the recession, it is recession. Or in depression, it is a prolonged uh, recession, or you can say that depression is occur for the long time period. So this pink line is basically showing the long-term secular trend above at the cyclical variation. So this chart is from the book. You can see the battery, national battery retailer example from the book as well. So moving on to the next slide. So here is the seasonal variation sample chart. The sales of baseball and softball equipment, uh, Hercher Sporting Goods, 2003 to 2005 by quarters. So if you can see that at first 2 quarters, the organization and the schools are purchasing the equipment for upcoming seasons. So in first 2 quarters, we have a higher sales. Then in third quarter, it goes down at a low point, and then it again a little bit moved up. But this is the seasonal variation. When we have a peak season, the production of the product will be increased, or the sales of the product is also increased as well. So this graph is basically showing 3-year quarterly sales of the baseball and softball equipment, and in every year it shows that in first 2 quarters the sales are higher. So moving on to the next slide. So this is the example from Excel. So this example is showing a secular trend. Home Depot is basically the second largest retailer store, where the number of associates increased from 1992 to 2006. So it shows the secular trend. In next example, we have a EMS call services. EMS call services is a basically emergency call service, which shows the seasonal variation, and the data of these EMS call services given over here, and the years are given over here. So moving on to the next slide. So this shows the secular trend of the seasonal variation. So this one was showing the cyclical variation, and this one is showing the seasonal variation. So you can read these examples from the book. It simply plot these values at the chart. So after completing this chapter, if we have lectures left, we will sorry we will do the Excel exercises. So at that point you will easily understand that how we can plot these points on the chart. So moving on to the next slide, the moving average method. Useful in smoothing time series to see its trend. So it basically smooths the data, and we can see the trend. So it's a helpful method to drawing a conclusion from the given data points. The basic method used in measuring seasonal fluctuation. So we can also find the seasonal fluctuation if the data had, then applicable when the time series follow fairly linear trend. We can also see if the time series data is following linear trend or it's linear. So have a definite rhythmic pattern. So this is the use of moving average method. So what are these 3 uses? The first one, smoothing the time series data. The second one is the use for measuring the seasonal variation or fluctuation. The third one is to fairly show the linear trend. So clear out all drawings. Let's move on to the next slide. So here we have the moving average method example. So this is the Excel example is printed over here. Here we have years, and then sales in millions, and then M is 7. It means that moving average 7 years. So we are dividing each value by 7 and then getting the answers. So this pink line is basically showing the moving average 7 years, and this blue line is basically showing the sales of sales. Here we have the years from 1961 to 1981 to 2005, and here we have sales. So let's move on. So let me clear the slides. Okay, here we have 3-year and 5-year moving averages. So if you can see, the data of production is given over here. So this black line is basically showing the variable of production, and the red point is showing the 3-year moving average data. So it also showing the cyclical variation, but at green point, if you can see, there is a 5-year moving average. So it smooths out that fluctuation and turn into a secular trend, or a straight, almost a straight line, or it shows small fluctuations in the data after using the moving average method. So basically this slide is describing the usefulness of the moving average method. So next is the weighted moving average. A simple moving average assigns the same weights to each observation in averaging. So simple moving average is assigning the same weights to each average, but on the other hand, weighted moving average is assigning the different weights to each observation. Most recent observation will get the more weight, and the weight decrease for the older data values. In either case, the sum of weights is equal to 1. So these are some points for the weighted moving average, or you can say the main differences between the moving averages of the weighted moving average and simple moving average. So starting from the example of moving average. So here is the data given for computing 3-year moving average and 3-year weighted moving average with the weights of 0.2, 0.3 and 0.5, which is equal to 1. So the sum of weights should be equal to 1, and the recent year get the highest weight. So these are two conditions for the weighted moving average. So moving on to the next slides, and let's see how to calculate the moving average. So I think that the calculation of moving average is not given over here. So I'll describe the calculation or the solution for the moving average first. So we will calculate moving average for 3 years here, because this is the answers for the weighted moving average. So for moving average of first 3 years, we will add up these 3 values and then divide it by 3, and we will get the value of so it will be like if I write down here 5, 7, 6, 1 plus 6, 1, 4, 8 plus 6, 7, 8, 3. So add up these three values and get divided by 3. So we will get the first value of moving average. Then we will calculate it for the next 3 values, which will be 6, 1, 4, 8 plus 6, 7, 8, 3 plus 7,445 and divided by 3. So we will get the, here we will get the first value, here we will get the second value, and we will move on in that particular way. So at the very first point, we add these 3 values and divided by 3, and after that we will add up these 3 values and divided by 3, and Then we will add these three values and divide it by 3. So we will move this average by averaging 3 values. These 3 values, and then next will be these 3 values. So we will add up these values and get the answers for the moving average for 3 years. But in the case of weighted average, we first multiply 0.2 with the uh, last year of the data, which is 1993 from the current year. So we will multiply with 0.2, then subsequent year will be multiplied by 0.3, and the most recent year of the third year will multiply by 0.5. The most highest weight will be multiplied by with the recency year value. So we will multiply with these weights, and then we will add up the values, and we will get the answers for the weighted moving average. So this is also work in the same way as we have did before. So the one difference is that we will multiply the weights with the values and then move with the gap of 1 year or next consecutive 3 years. So we will calculate the moving average in that particular way. And weighted moving average will use the weights and multiply those weights with the data values or data points. So let me clear the drawings. This is the calculation for moving average and weighted moving average. So in next slide, it is plotted the data into this chart, and this pink line is basically showing the 3-year moving average, and this yellow line is showing the 3-year weighted moving average, and blue line is showing the variable named attendance. So the weighted moving average is following the data points more closely as compared to the simple moving average method. So weighted moving average gives us a more appropriate results than the simple moving average. So moving on to the next slide. So there is linear trend. We will study linear trend in next class, inshallah. So at this point, we are finished today's lecture. Please try to solve all the examples and relevant problems, and contact me if you face any difficulty regarding the understanding of the concepts. Thank you so much. Allah Hafiz.